Consider two binary images shown below. So these are two images, image 2 and image 1. White square represents the 1. So white square represents 1, that is class 1, and the black square represents 0. Black represents 0. Suppose we use MP neuron to classify these two images. So MP neuron is the basic building block of the deep learning. How the MP neuron works? Why MP neuron is used to classify these two images? So MP neuron acts as a linear classifier. Classifier means it divides the entire data points into class 0 or class 1. So linear classifier, it divides it separates the two data points, class 0, class 1, into two classes, separate classes. How it separates the data points, classifies the data points by calculating the g of xi. How it separates the data points? It acts as a linear classifier. So g of xi, by calculating what is meant by g of xi? G of xi is the sum of the input signals x of I. So I equals to 1 to number of data points, this one. So it classifies, that is it predicts the output y hat equals to 1 when g of xi is greater than or equal to 0, otherwise 0. It classifies the data points, not 0. This one is theta, that is threshold, threshold. So by calculating the threshold, it separates the different data points into different classes, class 0 or class 1. So it is called as a linear classifier. So MP neuron is used to classify these two images, that is it is used to separate the class 1 data points, class 2 data points. In this question, the input is two images of size 5 cross 5 images. 5 cross 5 images. Turning the image of size 5 cross 5 into vector size of, so this is a image, it is flattening into a vector. Vector means it is in one dimensional direction. One dimensional. Vector means one dimensional, always one dimension is 1. So it is flattening into 25 cross 1. That is images have pixels. So is these two images are same? Because black represents 0, white represents 1. So the number of black pixels, that is the area of the black pixels in image 2 and image 1 are different. So these two images are different. Next, then the statement that these two images are linearly separable. So what is meant by linear separable? So linear separable means that is linear, it acts as a linear classifier, that is to separate the data points into class 0 or class 1. So that is there is a, in two dimensional there are so many data points. For example, there are two types of data points here. These two types of data points are separated by this line. This is called the decision boundary. So these data points are linearly separable. These data points are LS, that is linearly separable. If in two dimensional, so here to separate these two data points we use a line. It can separate the two data points by using the line. In three dimensional, it is a plane. Plane is used to separate the data points. So plane just like this. For example, XY plane, like that. In higher dimension HD, in higher dimension we use hyperplanes. To separate the data point 25 cross 1, that is there are x1 to x25 data points are there. x1 to x25 data points are there. So in higher dimensional HD, it is easy to separate the data points. That is linear separable is true. Why it is not false? Why this is wrong option? Why insufficient information? Not possible to decide. So generally these two images, the above two images are distinct images. Two distinct images. Two distinct images. Why these are two distinct images? So there are unique points. That is, so for example, in this image 2 has 1 2 3 4 5 6 like this. So different data points are black, different data points, different pixels are white. So these are different than image 1. Image 1 2 3 4 5 6 7 8 9. So total 25 points, 9 are black. So in image 1, so there are two different data points, black in image 1, black and white. So black data points are 1 2 3 4 5 6 7 8 9. So 9 and 16. Total data points equals to total 9 plus 25 equal 25 data points. Vector size. So these are different. For image 2 also these are different. So these are two distinct unique data points. So that is you can pass a hyperplane. So these are not in 2-dimensional. So these are in higher dimensional. So hyperplane is used to separate these data points. It is possible to separate separate the two classes of data points. That is, these are linearly separable points. How these are linearly separable? That is, we can find the threshold. If we can find the threshold theta, if we find the threshold theta, it can separate the data points. So how you can find the threshold theta? Threshold theta is finding by using this formula. So g of xi is less than theta. So theta, this is sum, that is xi, sum of the data points. So in this image, the sum of the data points, white pixels, is different than. So it is possible to find the threshold, that is sum of the inputs xi, sigma xi. In image 2, white pixels, if we add, sum is different than the image 1 white pixels. So these two images are different and two different points are linearly separable if we can find the threshold theta. So these two data points are linearly separable. This option is wrong, is not linearly separable. So we can linearly separate these two images. How we can separate? Because we find the threshold value. How you can find the threshold? By summing the input points. So there are two different input points, we can separate. Two distinct images. This one is important. If these are two distinct images, we can separate. We can separate by using geometry. Geometry and both algebra. By using theoretically these two concepts, we can separate these data points according to linear algebra 2-point rule. 2-point rule. What is this 2-point rule? 2-point rule means two distinct data points in n-dimensional space are always separable. So by using this theorem we can separate these two data points. So there is insufficient information is wrong. There is sufficient information. We have sufficient information, we can separate these two images. So it is correct, and not possible to decide, this is also wrong. We can possible to decide these two images are linearly separable. For example, if the same question, if the two images are two only, if the given two images are same, if the two images are same, if both the images are same, so that is image 1, image 2, instead of 1 and 2, if they gave 2, both images are same, these are identical images. So that is x1 equals to x2, x1 equals to, these are not separable. These are not separable because it has black and white, that is class 0, class 1 points, number of points are equal, same points. So these are same images. These are not separable because they are on the same side. That is, if we, how we can separate these points? By calculating the sigma xi, that is threshold theta. By calculating the threshold value is same. If threshold value is same, exactly same for both 2 points. So for example, if the data point is this one, this is image 1, which is 2, and the same data point is also 2, that is both are identical, right? Same images, how you can separate this data point? So because this is the same data point, so there is no plane, no line and hyperplane hyperplane does not separate these data points. Does not separable because both are same, identical. So this is not possible. Only these two images are separable because these are distinct. Distinct is very important. If both are distinct, you can separate these two images. Friends, if you please like my channel and subscribe. Thank you for watching.